Welcome to Pre-AP Chemistry Podcast 2.1 for Mrs. Mahoney at Saxe High School. Today we're going to talk about that quantity known as the mole. And it's one I know I've just kind of thrown out there, and let's just talk about what exactly does that mean. Is it something on my face? Is it a furry creature? Is it a chocolate sauce? What is a mole? Let's go to something we do know. A dozen. How much is a dozen? 12. Not Baker's dozen. Let's not try to count those because I think that only has 10. But you know a dozen is 12. Dozen roses, 12 roses. Dozen donuts, 12 donuts. A dozen means 12. You have other weird words. A gross is 144. A ream of paper is 500 sheets of paper. Different words can mean different numbers. It's a counting number. If I have 36 eggs, I can say 3 dozen. More convenient. I have 144, 12 dozen. Now looking at that, remember the mass isn't the same. If I have a dozen golf balls or a dozen bowling balls, the dozen bowling balls are going to have a higher mass because each individual is different. Same thing when we start getting into mass. Remember, just because I have the same number doesn't mean the mass is the same, because each atom is going to be the same. It's going to be different. Is not the same. So chemists came up with the mole. I believe it's based on the molecule, and we talk about how many molecules. I don't know for 100%, but that's what we're going with. This is our national little chemical society when we have mole day. This is the mole that you'll see. And there is a Mole Day website. You can Google it. You can see it. That's on October 23rd, 10/23. October 23rd is Mole Day, just like you have Pi Day, which is 3/14. We'll see if we're going to do any Mole Day festivities. We'll have to see when it falls. Okay, it's an SI unit. Moles to chemistry is our dozen. It's our counting. And they based it on the number of atoms and exactly 12 grams of a carbon-12 isotope. That was just our standard. So they said, okay, this number, we're going to use that as our reference from here on. So everything's pretty much in relative to that. And in respect for an Italian chemist, Avogadro, they named it after him, and that number is 6.022 times 10 to the 23rd. I could write that all out. But if I'm looking at this, 6022 followed by 19 more zeros, this is why we like our calculators that can handle scientific notation. We're going to be using this number a lot, and I don't want to have to always punch that in the calculator. So how big is that number? So let's just kind of look at some of the different things that we can see with that. If I had a watermelon, it would have to be a little bit bigger than the moon. Look at the donut holes. Are you hungry? It'd cover the earth and be 5 miles deep. You can kind of pause and read through that and just to get an idea of how big that number really is. In fact, somebody has made a song for it. So after watching this, or you can pause now, go check out this video. It's called A Mole is a Unit. I'll probably even have it playing in class tomorrow. And they have some pretty good comparisons for you to understand how big that mole is. And listen to a mole of pennies, of how much money that would be. So if somebody offers you a mole of pennies, don't turn it down. It's something you want to take. But I think is really interesting is the end when they said, okay, that's a huge number. It's really, really big. So that must mean it's really, really big. But then they said, wait, you can hold a mole of atoms in your hand. I know that you all probably drink many, many moles of water in a given day. So think of how many molecules of water you're consuming when you just drink that bottled water. You go to the water fountain, take a drink. You're down in close to a mole. Every 18 milliliters of water, you have drank another mole of water. So what does it mean? Look at this. Looks like a bunch of conversions to me. If I just have moles of something, anything, I can say I have a mole of shirts. I would have 6.02 times 10 to the 23rd shirts. Obviously, my husband might think different, but I do not have that many clothes. If I have a mole of atoms, 6.02 times 10 to the 23rd atoms. If I have a mole of molecules, 6.02 times 10 to the 23rd. So if I bake a brownie and tell you it has a mole of calories. Okay, probably not exactly that many, but you get the idea. It'd be a lot of calories. This down here, the mass of it, we'll be coming back to this because we do have to realize they have different masses and we can figure it out. But for today and for this week, this is what we need to work with. That's 6.02 times 10 to the 23rd. That's the number we're interested in. So let's look at the vocab. What's the difference then between this? Atoms, molecules. What's the difference? So this is where you may even want to write down somewhere in your note packet for some of the difference. And it's just purely some vocab. So I would say I have a mole of atoms if I'm counting like single elements. Silver, hydrogen, iron. That would be a mole of atoms because I'm looking at just the single elements. I start talking molecules, then I'm looking at compounds, water, carbon dioxide, sulfuric acid, H2SO4. That's a molecule. So if it's a compound and if it's a covalent compound, we call it a molecule. Okay, now over here, and part of this vocab we haven't gotten to yet, but this is covalent. Now if I have an ionic compound, which is made up of, let's say, table salt, sodium chloride, I could have magnesium fluoride. Metals, nonmetals, they make ionic compounds. We just call them a formula unit. It's just different vocab based on the kind of compounds. But to be honest, right now, we don't know the difference between the compounds looking at it. So we're just going to call any compound is going to be called a molecule. That's what we're going to look at. If it's a molecule, it's a compound. If we're looking at an atom, we want to look at a single element. Just a vocab difference that when we set dimensional analysis, but the number is exactly the same. So let's do some of that. So if we look at that, it just sets up great for dimensional analysis, which I know you're all so excited about. So look at what it wants to know. How many atoms in that many moles? So you should be working these with me. I also want you to have your calculator out and you can pause it so you can punch it on the calculator to make sure that you're getting the right number, because you really need to be using that exponential notation button. Get that E on there. So I always write what I know, 2.25 moles. And then I'm going to just set up my dimensional analysis. Okay, moles, so they have to be opposite. I need to have moles on the bottom. Now moles, M-O-L-E-S, M-O-L. This is the abbreviation that's written all out. It's the same thing. Sometimes I'm inconsistent, so please don't let that confuse you, and I will try to be more consistent. So I know it's that many, 6.02 times 10 to the 23rd atoms equals, I'm going to punch that in the calculator, so 2.25 times 6.022. Remember, this takes place, that should go in your calculator's E, no times, no 10, and you get as your answer, and we can have three significant figures. I would get 1.35 times 10 to the 24th atoms. More specifically, what is it? It's atoms of silver. One step, dimensional analysis. This is why we've been learning this, so that we can apply it to the chemistry. Okay, second one, I want moles. Where do I want to go? Molecules. What's the only difference? Water, H2O, is a compound. That's why I called it molecules instead of atoms. But the setup, I have that many moles. I want moles on the bottom because I want to cancel out the moles. I know 1 mole is equivalent to 6.022 times 10 to the 23rd, and I just label it different. Only difference. The math, I'm still going to multiply. I can only have two significant figures, so I have 2 in my answer, and I get 5.2 times 10 to the 23rd molecules. Okay, the next one. If you look at it, I have 8.5 times 10 to the 22nd. This time I have molecules, and I want to go to moles. So write down what I'm given. 8.5 times 10 to the 22nd molecules. Notice I'm not abbreviating these moles because that is different. Molecules and moles are different. But this time molecules needs to be on the bottom because they have to cancel out. Times 10 to the 23rd. Molecules. Now sometime I have to admit I take a shortcut and I call them MCs. 1 mole. Molecules cancel. Make sure of that you want them to cancel. So this time you're going to divide. Now this is where you have to be really careful that you enter it correctly in the calculator. You want this to be the scientific notation, that that's an E to the 23rd. Otherwise your order of operations will get confused because your answer should be 0.14 and your label is moles. And then always kind of go back. Does that number make sense? Well, look at this exponent. It's less than 23, so I should have less than a mole. I do have less than a mole. I'm comfortable with that number. It makes sense that I have less than a mole. Okay, this next one, we just need to look at a little bit of the vocab. So it's asking about hydrogen atoms. Okay, but wait, in water. We said water is a molecule. And if I look at in this molecule, there's not just hydrogen atoms. So this is actually, I'm going to have to take a second step. First, I'm going to have to go from moles. Then I can go to how many molecules. Then I'm going to count a little bit further and say, okay, how many atoms? So let's first go to those moles, to molecules. This step is just like we were doing. So I know 1 mole is 6.02, lost my period, times 10 to the 23rd molecules. Okay, but then I said there would have to be a second step. Let's look at a water molecule. Water's made up of oxygen and 2 hydrogens. That's 1 water molecule. That's 2 water molecules. So let's look. Each water molecule is composed of 2 hydrogens and 1 oxygen. This has 2 hydrogens and 1 oxygen. So if I have 2 water molecules, that has 4 hydrogens, is in 2 molecules. All we're doing is counting. And how do we know? It's from this. That's telling me that there's 2 hydrogens. So this last step then, I'm just saying, okay, in 1 molecule, there's 2 atoms of hydrogen. Notice how much words I put when I'm doing dimensional analysis, so that when I go back I can double check and I'm saying, does that make sense? So then I just do the math. 0.87 times 6.02 times 10 to the 23rd times 2 equals 1.0 times 10 to the 24th atoms of hydrogen. Okay, tomorrow we're going to be practicing all these conversions and come with questions of what doesn't make sense or something that I worked. Tomorrow will be your time in class that we can clarify this and hopefully make that mole a little bit more clear. Then realize it's not just a fuzzy little creature and it's not something to be scared of. See you tomorrow.